All right, here we go. Day 8 notes. We're going to look at 10.7 and just a little bit of 10.8. And then you'll have the quiz later on today. All right, 10.7, there's going to be two parts um, concerning kind of the same thing. We're going to look at area of a circle and parts of circles. Area of a circle, hopefully it's a familiar looking formula. It's A equals pi r squared, right? Um, so for pi on your calculator, when it asks you to round, you're going to use the pi button. Here I have the calculator up. I know it's a little hard to see, but right here, this is the exponent button, and right above it is the pi symbol. Okay, so you have to press second and pi, right? So second and pi, all right? So in the past, your teachers might have said to use 3.14 maybe. Um, we are not going to do that, all right? Okay, so in your directions, if it says to round, then you're going to use pi, all right? Okay. Um, so pi r squared. A sector is part of a circle, and notice, and this is going to be key in a couple slides. A sector is formed by the central angle, right? Meaning the angle is at the center. Okay, and so the area of a sector is the measure of the arc. Okay, the measure of the arc, and don't forget the measure of the arc in degrees is also the same measure of the central angle. Okay, so the measure of the arc over 360 times the area of the circle, because you're taking a certain portion of 360 degrees and then multiplying it to the area of the circle itself. All right. So here are some examples of finding the area of a sector. I know it's a little bit hard to see, but the slightly darker region is the shaded sector. Okay. So here in number 2, we first got to figure out this in green is our first step, right? 45 degrees divided by 360 is 1/8, right? If you can simplify. So 1/8 times the area of the circle, which is 324 pi. Now it says leave your answers in terms of pi, meaning you should have pi in your answer. All right, we're not going to multiply 81 times pi divided by 2. We're just going to leave it as 81 pi over 2. All right. And so these are some similar problems here in 3, 4, and 5. Okay, so take a look here. The green can be is one step, and then the red is another step. Okay, all right. Then it's a word problem, just without a visual. Okay. Here, I've seen this kind of trick students, right? Diameter is 20, that means the radius is half of it. So some students will, they'll rush the work and they'll use 20 as the radius. Be careful, all right? And so here we're going to leave the area as 100 pi, and then 208 divided by 360 is 26 over 45, all right? You want to make sure you use a fraction. Don't use decimals here, okay? And again, this is what's called an exact answer. All right, you're not rounding. This is an exact answer using pi and a fraction, simplified fraction at that. Right. Then you have what's called a segment of a circle, right? Now you might think, well, isn't that a sector? Isn't it part of a circle? No, a sector is bound by the central angle, right? A segment is somewhere not connected to the central angle. Okay. Right, so you have the area of the segment. Okay, part of a circle bounded by an arc and a segment joining its endpoints. Okay, so notice there's nothing about a central angle here. Okay, and so the concept here, right? You have the area of the sector, right? Like here, this would be a quarter of the circle, right? Because 90 degrees over 360, okay, minus the area of the triangle would give you the leftover portion. That's that segment, right? So that's the idea here. We try to color code it here for you, area of the sector in purple, minus the area of the triangle in green. Okay, now this might sound silly, okay, but I've seen it happen. You would not write negative 100 pi, right? These are not like terms. You're also not going to, again, multiply 100 times pi and then minus 200 and give a decimal answer unless it asks you to round, okay? If it says to leave your answer in decimals and round, then you're going to do everything that I just said. But the direction here says to leave your answer in terms of pi and radicals if there are radicals. And so this is completely acceptable. You're going to leave it as 100 pi minus 200 here. Okay? Again, here's another similar problem. Area of the sector, this whole thing, right, minus the area of the triangle gives you the leftover segment. Okay? Now for the area of the triangle, right here, okay, this is 120, so the central angle is 120, that's key. And then when you draw the height for this triangle, right, it cuts that 120 in half. That's how you know that's 60. And so you've created a 30, 60, 90 triangle. Okay. So the radius here, 9, acts as your hypotenuse. And so therefore, half of that is going to be the shortest side because it's across from the 30. So that's 4.5. So that's your height for the triangle right here, 4.5. And then if that's your shortest side, then the medium side across from the 60 is 4.5 root 3, right? Now you need to remember the area of the triangle is height times base divided by 2. So this whole thing is your base. So you have to add another 4.5 root 3 to get 9 root 3. That's your base, okay? I've seen a lot of students in the past only use 4.5 root 3 as the base, okay? And so again, area of the sector, 27 pi, minus the area of the triangle here, okay? Looks complicated, but again, this is completely acceptable, all right? This is another similar problem to the previous one, okay? If this is 60 degrees for the arc, then the central angle is 60 degrees. And so therefore, this angle, I know we didn't write it, but this small angle right here will be 30 degrees, right? And again, using a 30, 60, 90 triangle. Again, same idea, all right? Here we have 75, right? And so the central angle is going to be 75. Now notice here, we did not use 1/2 base times height for the area of the triangle. Remember, there's another formula which is on your formula sheet, and it was on, I think, Thursday's lesson. If this is 2 feet, then this is 2 feet, right? Then, like I said, the central angle would be 75, and now you've got a side angle side situation, right? And so that's what this is here, right? 1/2 of 2 times 2, the two sides, times the sine of 75, the angle sandwiched in between. So multiple ways. Now, since you are using sine, you are going to have to round here. Okay, so problems like this one, you'll probably need to round. I believe this is part 2. Okay, find the area of each shaded sector. Again, same ideas here. All right, this is kind of a review of day 1. Leave your answer in terms of pi. All right. And then we get into some more complicated stuff. Right, it says assume that all polygons are regular, meaning all the sides are congruent and all the angles are equiangular, right? It says here the diameter of each circle is 4 inches. Now, if you notice, we drew this, right? And we drew this line here, okay? And so if the diameter of one circle is 4, then the length of this rectangle must be 8. And if this diameter is 4, then the rectangle is actually an 8 by 4. And so the idea here is the shaded region for number 1 is the area of the rectangle minus the 2 circles. And that gives you these gaps, right? And so that's what we did here, right? The area of the rectangle is 32. The area of the 2 circles, that's what this 2 is here for, outside here, right? And pi r squared for 1 circle. So we have 32 minus 8 pi, okay? Please don't write 24 pi. These are not like terms. We're going to leave it as 32 minus 8 pi, okay? And over here, same idea, okay? Area of the circle minus the area of the trapezoid, all right, gives you the leftover shaded region, okay? Area of the trapezoid is 1/2 times the height times the sum of the bases, okay? And here, d equals 10, that's the diameter, all right? And so that's how you know the radius is 5, half of that. Again, same idea, area of the big one minus the area of the smaller one inside. Okay. This one is the area of the outer circle minus the area of the smaller circle. Okay. And more of the same here. All right, take a look at these examples. Again, more. All right. Okay. Hopefully you can follow these, and I think the color coordinating definitely helps. All right. Area of the large minus the area of the small. Okay. And then in 10.8, we're just touching upon this very briefly. It won't be on the quiz, but it might show up on the final. And so we're just doing our due diligence here. Geometric probability. Remember, probability is part over a whole, right? The possibilities, what you want, the favorable, divided by all the possibilities, right? And so here, find the probability that a point chosen at random in each figure lies in a shaded region. And so it's a mixture of 10.7, what we just looked at the past couple slides. All right. Here you have the overall rectangle, okay? And the shaded region turns out to be a rhombus, okay? You have diagonal 1 and diagonal 2. This is diagonal 1. It's given to you as 12. Diagonal 2, it's not drawn in, but this length, the diagonal, is the same as this length, so it would be 16. Right? Okay, so the overall rectangle is your total rectangle, right? The shaded region is 96, and so the probability is 96 over 192, and so the probability is 0.5 or 50%, right? And so here, number 2, you have the square minus the circle, right? You have, or not minus, but you have the area of the square, and you have the area of the circle, and so, or actually it is the square minus the circle, 144 minus 36 pi over 144, right? The 144 minus 36 pi represents the shaded region here, okay? And just a couple more of these. All right, look these over. Okay. Again, not on today's quiz, but I might redirect you to this for the final. All right. As always, if you have questions, please shoot me an email. All right. I have my laptop generally open throughout the morning. Okay. Or I'm checking it on my phone. So yeah, shoot me an email, and don't forget, there's an optional Google Meet at 11 o'clock this morning.